You got me there. My niece plays Minecraft, and she's given me the whole pitch as you guys, because actually she's slightly older than you guys now. It was always interesting. I could talk about her as being like younger and then the same age, and now she's older than the middle school kids I teach. But all right, maybe I'll give Minecraft another shot. But here we go. It is December 1st. It is a snowy December 1st. So how about this first day of December? Feels like winter. But as you may have pieced together, or maybe didn't, as I didn't think about this until a member of the community was like, well, I bet you're sad that you'll never have a snow day again. And I was like, wait, crap, you're right. Because we're doing such a good job on remote and on Zoom that we probably won't have a snow day again. Now, even if we had snow days, we probably wouldn't have one today, right? The roads aren't that bad. I drove in here at like 7:45 and that was totally fine. I will say somebody drove off a Billingsley road last night. If you live anywhere close to Billingsley, it was bad enough last night. Somebody's car slid off the road, but looked totally fine. Looked like nobody was hurt or anything like that. So guys, last time we met, we were talking about exponential expressions. Some of you have worked ahead, like you utilized your Thanksgiving break and you worked ahead, and you've completed all the work due on December 4th. Most of us haven't, right? So today we're going to mainly be focusing on that work that is due on December 4th. So if we start a problem and you decide, oh, I already did that problem, I already know what to do, I'm giving you my explicit permission to work on something else, but only if you're done with your Khan Academy work. And that's about half of us, right? About half of us have worked ahead, half of us have not worked ahead. So that's why I still need to continue teaching about our exponential expressions and equations, because they get kind of tough. So let's write this down as a review of where we were last time that we met. So on our paper, if we go ahead and give it like a communal header, or something that's going to be similar for all of us, exponential expressions, exponential equations, you could just write exponentials. I don't really care what you title it. And by the way, for anybody with internet issues or anything like that, I am recording and we'll try to post this. I will not use first or last names together. Your guys' privacy and safety is obviously super important to me. The other thing I wanted to announce before I get too far and dive into things is that I have created what is called a community help document in our Schoology page. So if you go to Schoology, you'll notice the new stuff that we do, like Desmos links and things like that, will land here in the November 30th and beyond folder. Really, there's nothing there yet because this is the first day of class since November 30th and our switch back to remote. But the community help document right here, if it loads, and then I'm going to click on it again just to leave Schoology and go to Google Docs, is where not only can we like back and forth, like you guys with me, but you guys with each other can provide help and kind of alleviate some of that in between classes, because we only have class every other day now, which you had class every other day even when we were on hybrid. But I'm going to show you an example of what this looks like in one of my other classes. So you can get a feel for what I would like it to be. And then if you start engaging with me, our community help will start to look something more like this. So when students email me a question, I drop it in the community help doc, and then I create a response either written or in a video. So this one I created a video response, and then I post it in the community help document because let's say Jimmy is doing his homework and Billy hasn't done his homework yet, and Jimmy has a question and emails it to me, and I put a response in our community help document. Well, then when Billy hits that same problem and is like, oh crap, I don't know how to solve this, Billy could come look at the community help document and benefit from Jimmy having asked that question. Does that make sense? I'm trying to help you guys like benefit from each other's struggles and whatever else. The other thing of that is Susie, and of course I'm making up a bunch of names that are like old school names that kids aren't really called that much anymore these days. Let's say Susie comes in here and didn't even realize that she was going to have a question about this. But she's like, oh, before I even get to that, I can understand a bit more about it before I even try that problem. Or let's say Jamie comes on and is like, oh, I also struggled on that problem. I'm going to leave a comment and say, I also struggled on this problem. This is what I did, right? And like you could write a comment and be like, okay, this is how I was able to solve it, because how I describe things is not always like the end all be all best way to describe them. There's a lot of research that says kind of kids talking to kids is sometimes more effective than adults talking to kids or explaining things. So on that note of kids explaining things is even more beneficial, who could explain how we deal with 6/17 to the 9x being rewritten as a to the x? So if we want to write this down, I'm going to use blue because it's snowing outside and it's winter. Actually, is it winter yet officially? I think it's still fall.
Technically it is still fall, but I'm very happy that our actual first snow was November 1st, and this is our first big snow.
Yeah, December 1st, you mean? Yeah, I'm with you. December 1st seems appropriate for a nice snow.
It's not, if it snows, it should be winter, but winter doesn't start till 4
20
days before, like it doesn't start till December 21st.
Yeah, I thought it was the 21st. I'm sorry about my camera. I'm going to keep trying to put other things in the frame to get it to stop focusing, or I might just flip a little switch and see if it'll just stay focused. All right, anyone got suggestions for me how we deal with this? A only has a power of x, and we want to say what a could be so that these things are equal. What will we need to make a in order for this to be true? Excuse me, this is one of our Khan Academy problems that we've already solved, right? Look at what is common or what's like shared or what doesn't need to change. Well, the power of x on both sides is totally fine. How do I get the 9 in the power with another value? Well, these are multiplied, but who can remind me how we end up with powers multiplied by each other?
A power to a power.
Yeah, thank you for just shouting out. Guys, use that space bar, right? I forgot to encourage that at the beginning of class. If you're going to sit on mute, that's totally fine. Like if your house has some background noises or whatever. But your space bar, just reach down and tap your space bar and that unmutes you quicker than you can even probably use your mouse to get to the unmute button. So if you're looking at Zoom, just use the space bar to unmute yourself. So we want a power to a power. So we want 9 to be raised to the x. Right? Well, okay, so a power of 9 raised to the x, so a is going to involve a power of 9. So what else should a have? The base, right? This base of 6/17. So if we give a base of 6/17 to the 9th to the x, that would get 6/17 to the 9x. Right? Are we all with me? Are there any questions on how I decomposed this 6/17 to the 9x to be 6/17 to the 9th power to the x power? Any questions there? So then what we can say is, well, I'm going to put like a semicolon here, a must be 6/17 to the 9th power. Right? Leave out the x because the x is already over here on this side of the expression. A would be just what came before the x power. Any questions on that one? That's pretty much review. We actually talked about this problem the last day we met. Well, depending on what color you are, probably depends on that, whether blue or green. I tried to keep things the same, but it didn't always work. Any questions on how we deal with a problem like that? Otherwise, we will move on to this. So last chance to ask a question about this. Sorry that this is like kind of blurry. I tried to zoom in on my computer, but even zooming in on my computer, it kept it pixelated. So this is x over 12 as the power. Right, so let's go ahead and squiggly line. I'm going to put some green beneath the blue because there's still grass beneath the snow, right? I'm feeling very Bob Ross this morning. Who knows who Bob Ross is? Okay, there, good. Now you're making me feel less old. I have a Bob Ross disc golf t-shirt that says, "Try not to hit the happy little trees." And I think it's so great. Because, I mean, you guys disc golfed in gym probably. You know how it's like, my throw is awesome! Into a tree. Great. So, 2 to the x needs to equal a to the x over 12. Now, this gets more complicated because we have an x on both sides. And I'd almost rather ignore the multiple choice options. So let's ignore the multiple choice options. I'm just going to cover those up. So if I make a 2, right? That's kind of like a gimme that if we have a 2 in the base over here, a might involve a 2 in the base, right? That's great. But if a is only 2, then this side is going to become 2 to the x over 12, which doesn't work, right? I want it to just be 2 to the x. Any suggestions of what to do with our potential a value to fix this and make it turn into 2 just to the x? Because right now, if I make a 2, it's 2 to the x over 12. That's not what I want. How do I get x over 12 to just turn into x? Sorry, my nose is kind of running. And it's probably because it's like 55 degrees in this school because it's freezing. Guys, how do I get something that's divided by 12 to actually turn into just one of something? Because this is 1x, right? What do I need to do over here?
You times the exponent by 12?
Yes, multiply by 12 or get a 12 in the denominator, or sorry, in the numerator to cancel out the 12 in the denominator. So to get a 12 in the numerator, to multiply powers, right, we're going to raise a power to a power. So if a is 2 to the 12th, then, I'm going to change colors here for a then a to the x over 12 would become, didn't mean to write a, would become 2 to the 12th to the x over 12, which would become 2 to the 12x over 12, which is 2 to the x. So if we make a 2 to the 12th, then the division by 12 in the power will be reduced out to 1, is how we like to say it, not canceled out, but reduced out to 1 because a power to a power multiplies. So guys, some of what we're doing here is review of like exponent rules. So remember that a power to a power multiplies. If you need to make yourself a note off to the side, I used to on my math pages make little rule bubbles because they would stick out. So remember that if we have like a number like 2 to the a to the b, it's really 2 to the a times b. Or I can decompose and work backwards. And if I have a base to a power that is multiplied, I can decompose it to a power to a power. Now wait, while we're making little rule bubbles, what if instead of having a power to a power, we had 2 to the a times 2 to the b? What was our rule there? If we're multiplying, what are we actually doing with the powers? I will embrace the awkward silence until somebody wakes up and tells me something that we've already learned.
Add the exponents.
We add them, right? So this would become 2 to the a plus b. That's going to be necessary as we move forward and remember how to deal with these situations. So everyone please write down 3 to the 5x plus 3. And by the way, if you haven't done your Khan Academy, if you haven't worked ahead yet, what we're doing today is definitely going to help you as you get into your Khan Academy. So they tell us we want 3 to the 5x plus 3 times 27x, or to the power of x, sorry. We want to write it as, so equal to, right? 3 to the something. And guys, anytime we use this notation, what notation is that? Starts with an F. Starts with a fun.
Function?
Yeah, it's function notation. So it's saying what function goes in here. What function is in our exponent? What am I going to do? Somebody help me out.
You have
Just, yeah,
You
unless
have
we
to
talk over
change
each other.
You have to change the base of 27 to the base of 3.
Sweet. Now, Alina, you're not allowed to help for the rest of the problem. So I'm going to keep this the same. And what is 27 if I change it to a base of 3? Well, it would be 3 to the...
9.
Ellie's throwing a 3. Right, how many times do we need to multiply 3 to get to 27? Now, Katie Ann, you said 9 because 3 times 9 gets to 27. So that's why your brain said 9 goes with 3 to get to 27. But we have to think powers, right? So 3 times 3 times 3 gets to 27. And that's still raised to the x. So this is actually... What happens with this 3 and this x? Do they add or do they multiply?
Multiply.
Multiply. Are there any questions on how I've gotten from our start down to here? Roger that. So now, how do I decompose this addition in the power? Or do I decompose? Like, what do I do now? Alina's not allowed to help anymore. You already got your help for this problem. Margaret, Elle, you can maybe help. I guess you're allowed to help one more time.
You just add them, like the powers.
Atom,
You
like
add 'em.
like ATOM, like an atom.
No. 8x plus 3.
Sorry, you add them, right? You just said it like kind of pushed together, so I had to take advantage of being able to make... Yeah, so we add them, right? The bases are the same. My base of 3 and my base of 3 have already achieved what I want. So remember, and I have this, well, aside from part of it's blocked by whatever window this is dragging in from up top, we want to make the bases match. We've done that. Now that we make the bases match, we just deal with the exponents how we're supposed to. So you said we add them, so this is going to become 3 to the 5x plus 3 plus 3x. And then combine like terms, I'm guessing. Because we always combine like terms if we can. So 3 to the 8x plus 3. Is that what we're getting? So let's review what we did. And then we got to talk about why the answer is what it is. We started with bases that didn't match. We were told the base that we wanted to get to, so that was kind of a big help. We knew what our goal was, get to a base of 3. We changed 27 into 3 to the 3rd. We then combined the power to the power through multiplication. We then realized that when we have the same bases and we are multiplying, the powers want to add with each other, or need to, or do. And then we combine like terms, which tells us that if 3 to the f of x is equal to this, then f of x must be 8x plus 3. Any questions on that problem? I'm going to leave that screen up while you look at this one. Go ahead and try this on your own. This is slightly different. And harder. Man, so write down the original. And when it says, like, you know, rewrite as, we know they're actually going to be equal to each other. Four times x plus 3. Now, if you're one of the people that worked ahead, but you haven't done this in like a week, you should be paying attention because it's easy to forget about some of these rules or make some slip-ups. So now they're giving us a coefficient in front of our exponential expression. So 4 to the x is our exponential expression, but apparently they're giving us this a to solve. So what we're being told here, if we want to make some notes, is my power of the x needs to be 1x, right, is what that looks like. They want just 1x. And we're going to find some coefficient that looks like it's going to be a number because there's no other variables. So probably a constant there. Can I combine these using this subtraction? Can I combine those using that subtraction? What do you guys think?
It would have to be, if you subtracted it, it would be like dividing. No.
Division leads to subtraction, but we can't turn that rule around, right? Like division of powers, we end up subtracting the powers. Yeah, that doesn't work backwards. Okay, so let's ignore that for a moment. That was another thing that Dr. Smith was really good at saying is, sorry, I talked about him earlier in a video that I was making for another student. Dr. Smith is like my favorite professor from Otterbein. He always said, like, if you can't do it, draw a picture. Like, if you don't know what to do to solve a problem, draw a picture. Or ignore the thing you can't do and do something else. So if we don't know what to do with this, how does 4 to the x plus 3 come to be? Like, how do we end up with an exponent that's adding? Somebody not Alina? Because she's worked ahead. I know she knows it. Also, if you can see her screen, she just told it to us, essentially.
You would get the x plus 3 in there because you multiplied 4 to the x plus 4 to the x times 4 to the
Yeah, absolutely. I knew right where you were going. You were getting a little tripped up trying to say it, but I got you. We get to x plus 3 in the exponent by multiplying using the same base, right? Base of 4 for each. 4 to the x times 4 to the third is how we decompose 4 to the x plus 3. Okay, so we got 4 to the x. Great, sweet. Drop this down. We still don't really know what to do with this. Well, if I just had 4 to the x minus 4 to the x, well, that would just be like 0, right? But we don't. Can I do anything with this multiplication that might help me get it closer to the form of a times 4 to the x? Calvin or Kaylin, I'm looking up at your guys' corner because you guys have been pretty quiet today. Is there anything I can do with multiplication to help us get closer to this form?
Couldn't you, like, swap them around?
Yeah, commutative property, right? Let's swap these around because the commutative property says I can change the order of multiplication and nothing happens. Man, if we only just had this, we'd be done. But wait, 4 to the third isn't anything that complicated. What's 4 to the third? It's 4 times 4 times 4. But what's 4 times 4? Yeah, you guys are all on mute. This is why I hate not having you at school. I know, yeah. And then this is where it gets tough. What's 16 times 4?
$64.
Yeah, 64. So I have 64, 4 to the x, minus 4 to the x, if I wanted to put this into this form, what number would we have here? If I wanted to put this, just 4 to the x, into the form a times 4 to the x, what number would be in front of this 4 to the x? What multiplication can we do that doesn't change anything?
1.
1! Yeah, like immediately a bunch of people were like, 1! It's 1! 1, right? This is 1, 4 to the x. So guys, if you ever want to just like throw in a coefficient, we can always use 1. 1 doesn't change anything. So if we have 64 times 4 to the x minus 1 times 4 to the x, what do we really have? How many 4 to the x's? What number goes here? What's 64 minus 1?
63.
63. So if that equals a times 4 to the x, then a must be 63. So guys, I know this one is tough because you have to kind of either have intuition, like someone who's been at it for a decade, or you probably have to struggle a little bit and figure out like, oh, this didn't work. What can work? I just realized my lamp is in the way of my camera. That's kind of funny. So, and it's only one of my cameras because I have to have two going at the same time. To review the problem again, we decomposed. Yeah, Elle, what's up?
I did something a bit different. I still got the same answer, but instead at the second line, I just divided it by 4x. Is that okay, or?
What do you mean? I wish you all had dot cameras on your desks.
4 to the x.
So you ended up using, like, you just divided each side by 4 to the x? Oh, to isolate. Yeah, okay. I see what you mean. So, oh, well, that also, we could do that through factoring, right? So if we wanted to, like, right here, that's a really cool, like, way to go. So let's put an asterisk, and I'm going to drop it down here. If you wanted to, we could say that we have 4 to the x times 4 to the third minus 4 to the x, which we said is just 1 4 to the x. If we factor out the 4 to the x, we really have 4 to the x times 64 minus 1, right? This is 64, and we said this is multiplied by 1, whether we put it in front of it or behind it. So what L is saying is if I have this factored out, and it's equal to 4 to the x times a, and I just switched the order just because it's commutative, right? So I'm going to put 4 to the x first just because. We can divide both sides by 4 to the x. Any number over itself, no matter how complicated, is 1. So we get just 1a, right? There's your giant 1 that you love. So 1a is equal to whatever's left in the parentheses, which is 63. So yeah, that's a really cool way that you can go about this problem too. And really, I probably should have put the arrow right here for going down and factoring. That would have been a better spot to drop the arrow. So that's another way. Just like getting to Disney, right? There's a lot of right ways to get there. It's all right. I don't know if your shoe ever comes untied and it just bothers you, but that's where I'm at right now. All right. Other questions on that problem? Ellie, you look a little disgusted. Does that problem make sense? I mean, for all I know, you're in the same room as a sibling and, you know, something just happened, so who knows? That's what's weird about all you guys being back on remote. Like, I just miss you guys being here. Oh, and those of you who weren't early to class missed the discussion about the Phoenix Ghost. So, parts of the slide didn't load. Come on! This is cheap. I can get the problem back really quickly. All right, so give me 2 seconds. Exponential form. it's not that. I think it's this. Sorry, you can see it right here, guys, right? I'm not crazy, but it's not showing up on my slide, so I need to go capture that picture again. So my question to you, how can you turn a 1 into having a base of 26? And here's why. If this is our problem, and this is one of the 4 problems in one of your practice sets. Are you kidding? All right, we're going to use this view. I don't know why Google Slides hates me today, right now, in this moment. Write this down in your paper, please. 26 to the 9x plus 5. Wow, this is complicated. Equals 1. Now, guys, I'm not going to lie, because a couple of you have asked, could we just solve these things graphically? Well, I don't know. Let's find out. If we went to Desmos and we went to our graphing calculator and we typed in the function 26 to the power of 9x plus 5, do we get a graph? Yeah, right? Like we get a graph. Can we graph where 1 is? Yeah, we got to tell it what is 1. Would we want y to be 1 or x to be 1?
Y.
Y, because we're operating with that top function being a y also, right? So we said this is a y, and this is a y, and our answer, I'm not going to click it, but it would be that point, right? It would be that intersection point. So yes, we can solve these graphically, but that's not what we're practicing, right? What we're practicing is doing the algebra to solve these manually. So my question again, man, if I want to figure out what x is, that's the only thing I have to solve here. I got to get these to have the same bases. How can 1 have a base of 26? I'm going to say, okay, 1. Remember what Dr. Smith said, if you don't know what to do, just write something. Just do something. I want 1 to be 26 in the base and have some power. I'm going to awkward silence wait until one of you guys jumps in to tell me what I should do with that right-hand side.
0.
Who was that? You can say it again. All right. L, I might tell you you can't participate for a few more minutes after this. So, 0, right? What power would make a base of 26 turn into 1? Well, guys, what power makes any base turn into 1? 0. A power of 0 makes any base turn into 1. Well, now this problem's really not very difficult. It's still kind of difficult, but it's not very difficult. We know that when we're raised off of the same bases, we can actually just set them equal to each other. So 9x plus 5 is equal to 0, or 9x is equal to negative 5, or x is equal to negative 5/9, which we know as a decimal value is negative what? What decimal do we get from 5/9?
0.5 repeating?
Yeah, 0.5 repeating. So if we come back to Desmos, negative 5/9. That 6 is a lie. Don't trust the last number. That 6 is a lie. Just like the cake is a lie. 6 is a lie. Who knows the reference I'm making by saying the cake is a lie? Anybody? Nope. Amar, do you know what game it is? What game am I referencing? Do you know? Ah. There's a really sweet game. It's probably one of the last video games I played. Where in the first one, there's this whole running theme of the cake is a lie. It's a game called Portal. And you literally have a gun that shoots an entrance portal and an exit portal. And it's like a puzzle game. It's a problem-solving game. No, it's so fun. You just got to start at the beginning and play from there. Get Portal 1. It's probably cheap now. Yeah, if you want another video game to add to your collection that is not like, shooting people and stuff like that, because I don't think those games are cool, I would say go pick up Portal. It's a pretty sweet, fun game. All right, so now we're going to ease into kind of a new area, and I will probably only keep you guys on here for like another 5 or 10 minutes. Right, we'd probably be done with class now if everyone was here, early or on time. But instead, we were on time or late. So maybe on Thursday, if we can all get here on time, we'll be done by now. So 3 to the 2m times 4 to the... Ooh, wait, this is different. Instead of having matching bases, we have matching powers. 3 to the 2m times 4 to the 2m. What do we do when our powers are actually the same and our bases are different? By the way, if our bases were the same, just to make that side note, let's talk about that because you're going to encounter one of those situations. So what if we had 3 to the 2m times 3 to the 2m? What's that turn into?
To the 4 or 9 to the 4.
See, this is where it gets real tricky, right? So, well, if we just had 3 to the first times 3 to the first, what would that give us? Guys, what's 3 times 3? Use your space bar.
9.
Thank you. I'm tired of doing all the math. You guys come here for class, not to just stare at a screen. You gotta participate. What if I had 3 to the first times 3 to the second? That becomes 3 to the third. Oh, so this also could have just become 3 to the second. So these are adding powers. Crap, but that's not... So... Crap, so that's 3 to the 2m plus 2, right, if we're just remembering all these rules. Anyone have an idea of what to do over here? L?
Am I allowed to say stuff?
Yeah, you're allowed to say stuff.
Backwards distribution.
So, decomposition, right? So we're going to decompose this is often what we say with like when we do things backwards. What do you mean? How am I going to rewrite this?
3 times 4 in parentheses with 2m. This is a power 2m.
The way that we end up with a same power on 2 different objects, and L, I like that you just said distribution, is when a power gets distributed. Now, wait, so do I just write 3 times 4 in here? I think, right? It's not addition, right? That's the only other thing I could think of is but adding wouldn't make any sense because, so think about it. If we have 3 times 4, guys, like I've said before, if you want to help you make sense of it, substitute something else. What if instead of this, it was 3 to the 2m times x to the 2m? Well, then we could say, well, that's like 3 times x to the 2m. And although we don't naturally, or I could have used like I or something that we wouldn't actually be able to combine, that puts x to the 2m power and 3 to the 2m power. So the same thing's going to happen over here. Excuse me, the way that we get multiple values raised to the same power is by having had them get raised to the same power. So what we can really say is this is actually equal to what? What's 3 times 4?
Uh,
12 and just to the 2m, right? The trap door there is that you don't combine the powers. They're the same, so they stay the same. Hey guys, if you read what I have typed at the top of the screen, it says that. This is what's funny about the human brain. I know that since what's moving and what's active is down here, that you probably wouldn't even read what text I had typed there. But please make sure that if there's like text typed up there, you might like throw an eyeball at it. So 12 to the 4m over here on our list, not equivalent. It's a trap door. Absolutely a trap door. Now wait, okay, down here 12 to the 2m, that is equivalent. What about 144m? Thoughts? Who wants to talk to that? Not Elle, not Alina. Avi?
If we raised power to a power, so we did 12 to the second, and then that to the m.
So if we take this, sorry that these notes are getting a little bad, and break it and say 12 to the second to the m, that's how we decompose 12 to the 2m, right? Because this is multiplication, so it was actually a power to a power. And well, that would give us 144 raised to the m. So yeah, 144 to the m would also be equivalent. All right, to try to preserve time, this problem, I'm going to talk through all 3 parts of this so you can come back to this video, and then we will probably pick up on this problem and or the challenge that doesn't want to load now. So guys, this problem is not as scary as it looks like, but I want to make you feel better. It looks crazy scary. So here's the deal. When we come down to each of these different options, they're trying to check, do we remember a specific exponential rule of how we can break things apart or put things together? So for our first expression here, because remember there's no equal, so it's an expression. Check it out and stop me, tell me if something doesn't make sense. We're told to rewrite this in the form of 100 to a power because that's what we have. In case this looks weird to you like it looks weird to me, this 0.05 seems too big. I don't like that their text is the same size. All of this is the same power. So we know that we want to put our values, and this is how you should approach each of these problems. What you can tell yourself is, I need to get to a base of 100, and then whatever power we have up here, however complicated it is, that's what I'm going to compare. Right? So when we start with our 50 to the t squared, sorry, that looks like a plus sign, times 2 to the t squared over 25. I shouldn't even write all this out. Okay, we don't have time for me to write all this out because there's so much writing. So I'm just going to talk about what I have copied here because I was kind of worried I was going to be running out of time. So watch what I do. Don't try to write. That just takes too long right now. You know that normally I would have you guys write things down. So check it. What we do here is utilize the rule that we just talked about, guys. When we have the same power, t squared and t squared, we combine the bases and keep the power. So if you don't remember that rule, this problem seems really, really difficult. But when we combine the bases and keep the powers, sorry, this power looks really weird. I'm just going to minimize this screen. We get 100 in the numerator, and we also get 100 in the denominator. Then this is a simple subtraction, right? Because we know when we have the same bases and they're dividing, we subtract those powers. So we get t squared minus 0.5t. So then we compare. Is that the same as the problem they gave us? Yes, we can conclude that this complicated mess of stuff is equal to 100 to the t squared minus 0.5t which is what our problem started with. Any questions on this really quick run through? I know this seems really complicated, but it's all about remembering the specific rules. In this one, we have 10 to the t squared over 100 to the t. So get everything to have a common base. How can I make 10 have a common base of 100? Or if you wanted to, you could have made 100 into a base of 10, solved it from there, and then switched it at the end. But because we know we want a base of 100, 100 to the 1/2 power, like the square root of 100, is 10. So guys, this is in my opinion, the most complicated part of like, oh, okay, that makes sense. Now that I see it, I can turn 10 into a bigger base by using a partial power, right? So roots. So square roots or cube roots or whatever, we can use a larger base as long as we then take a root. So I would actually rather see this as the fraction 1/2. It would make more sense to us. Or we could have said square root 100. And then what is square root 100? Actually 100 to the 0.5 power. Any questions on how we get this 100 to the 1/2 power? Then we remember our rule, power to a power multiplies, and then power divided by a power subtracts. It is not the same, right? It is not the same as our prompt, as what we started with. And the final part of this problem, sorry, I'll make sure that you guys still do get a 10-minute break. If you need to leave, if you need 10 minutes before your next class, feel free to hop off the call, go take your break. I'm just going to talk through this problem really quickly, and then that's it for today. We're going to start on Thursday with the problems from the challenge. So actually, I would like everybody to try to make at least a first attempt through the Evaluate Radical Expressions Challenge. It's due December 4th, but I would like everybody to try to make a first attempt through Evaluate Radical Expressions Challenge so we can talk about it on Thursday. So please try to do that today or tomorrow. Don't do it Thursday morning. That does not help me. Do it today or tomorrow so I can do our final prepping on Thursday morning. So here on the bottom option of is it equivalent or not, you can see at the bottom it does not come out to be equivalent. How do we get there though? Well, if the powers are the same, we just combine the bases. Doesn't matter if we're doing multiplication or division. Just remember, division is multiplication. They share the same rules. So since t squared minus 0.5t is the same for both of them, we literally just divide 50 by 5. And that's essentially our answer. But we need to get this in a base of 100. So to get to a base of 100, we take the square root of 100. That's what this is, like we just said. And we end up with this as our power. So if you have any questions, I'm happy to stick around and answer any more questions that you guys have. But aside from that, that's everything I have for you today. Sorry we're back in remote, but it is the safer option for right now. Cases are pretty high. So stay home if you don't need to go out. But go make a snowman. It's going to get warmer tomorrow and Thursday. But today, that snow is really good packing snow. So either during your lunch break or later after school, go make a snowman. Go have fun. So have a great day, guys. Unless you want to hang out and ask a question, that's everything I got. So thank you so much. I'll see you on Thursday.
What was the radical challenge thing that you were talking about?
It is this assignment. Actually, I can't. Well, you can't see any student names. So it is this assignment saying Evaluate Radical Expressions Challenge. I think you've already done it.
Oh, okay.
Yeah, I think that's one of the ones you already... If you've done everything for December 4th, that was one of the December 4th ones. Cool. Thank you, guys.
So like for the revisions for the